Welcome to educational channel of Suresh Bhatt classes. Quantitative aptitude video on speed, distance and time in every competitive exams like bank PO, CAT, GRE and other employment exams and placement interviews. 4 to 5 questions on speed, distance and time are asked. We are going to cover complete topic with basic formula, type of questions asked, shortcuts and tricks to solve these questions. Let us start the topic speed, distance and time. So we first cover the unit and conversion of distance, time and speed. So first we go for the distance. There are so many units of distances like millimeter, centimeter, meter, kilometer, and big units like light year. But in the competitive exams and aptitude questions, the units usually used are kilometer, meter, and miles. And we must know the conversion of the units like kilometer to meter. We have to multiply by 1000, and meter to kilometer we have to divide by 1000. We'll go for the examples of few questions of conversion of kilometer to meter and meter to kilometer. Second is time. The unit of time in these questions are usually hour, minute and second. And for conversion hour to minute, we have to multiply it by 60. Hour to second, we have to multiply it by 3600. Minute to second, we have to multiply it by 60. And second to minute, we have to divide the seconds by 60 to convert it into minutes. And seconds to hour, we have to divide it by 3600. Our third is speed. Unit of speed is kilometer per hour or meter per second or miles per hour. And for conversion kilometer per hour to meter per second, we have to multiply it by 5 upon 18, and meter per second to kilometer per hour, we have to multiply it by 18 upon 5. Now we go to some examples to learn the conversion of distance, time and speed. So we go to the examples. So we have to convert 4 kilometer into meters. So 4 kilometer multiplied by 1000. So we get 4000 meters. And if we have to convert meter to kilometer, say 5000 meters. So what we have to do? We have to divide it by 1000. So we divide 5000 by 1000. So we get 5 kilometer. Now we convert few fractional quantities. Let's convert 3.5 kilometer. So 3.5 kilometer, if we have to convert it into meters, what we do? We multiply 3.5 multiplied by 1000. So we get 3500 meters. Now we have to convert 7500 meters to kilometer. So 7500 meters, we divide 7500 by 1000. So we get 7.5 kilometer. This way we convert kilometer to meter and meter to kilometer. Now we go for the conversion of time. Let us convert 3 hours to minutes. 3 hours is converted into minutes. So we multiply 3 by 60. So we get 180 minutes. Now we convert 2 hours into minutes. So we multiply 2 by 60. So we get 120 minutes. If we have to convert 2 hours into minutes, we multiply it by 60. But if we have to convert this into seconds, we multiply it by 3600. So 2 hours equal to 2 multiplied by 3600. This gives us 7200 seconds. Now if we have to convert minutes into seconds, we multiply it by 60. So 8 minutes. 8 minutes when converted into seconds. So we multiply 8 by 60. So we get 480 seconds. Now converting seconds to minutes. 300 seconds. is converted into minutes. So what we do, we divide 300 by 60. So we get 300 divided by 60 is 5. This is equal to 5 minutes. Now seconds to hour. So we have 10,800 seconds. So we divide it by 3,600. 10,800 divided by 3,600. This gives us 3 hours. Now we convert some fractional part of hour, say 15 minutes. 15 minutes equal to 15 divided by 60. This is equal to 1 upon 4 hour. Or if we want to write in decimal, so this is equal to 0.25 hours. 30 minutes. 30 minutes equal to 30 divided by 60 equal to half hour equal to 0.5 hours. 45 minutes equal to 45 upon 60. This is equal to 3 upon 4 hour equal to 0.75 hours. So any minutes, if we have to convert into hours, we have to divide it by 60. Let's do one more. If we have to convert 40 minutes into hours, we divide it by 60 equal to 2 upon 3 hours. Similarly, we can convert 12 minutes into hours, which is 12 upon 60, which is equal to 1 upon 5 hours, and so on. So we can convert hours into minutes, minutes into seconds, second into minutes, and seconds into hour by this method. Now to convert speeds from kilometer per hour to meter per second. While converting the kilometer per hour to meter per second, we have to multiply kilometer per hour by 5 upon 18. So let's convert few kilometer per hour into meter per second. So we do 72 kilometer per hour. This is converted into meter per second. So what we do, 72 multiplied by 5 upon 18. 18 times 4 is 72. So this is equal to 20 meter per second. 90 kilometer per hour is 90 multiplied by 5 upon 18. 18 cancels 90 for 5 times. So this is equal to 25 meter per second. 108 kilometer per hour. We multiply it by 5 upon 18. 18 cancels 108 for 6 times. So this is equal to 30 meter per second. Now we convert meter per second into kilometer per hour. So 5 meter per second. When converted it to kilometer per hour, we multiply it by 18 upon 5. So 5 multiplied by 18 upon 5, this is equal to 18 kilometer per hour. Now we convert 15 meter per second into kilometer per hour. So 15 meter per second is multiplied by 18 upon 5. So 5 cancels 15 for 3 times. So this is equal to 54 kilometer per hour. We convert 40 meter per second into kilometer per hour. So 40 multiplied by 18 upon 5. This is equal to 144 kilometer per hour. So 40 meter per second is equal to 144 kilometer per hour. This way we convert kilometer per hour into meter per second and meter per second into kilometer per hour. Now we go to the formula used in speed, distance and time questions. So this is called distance, speed, time triangle. Here this is distance, speed and time. So distance equal to speed multiplied by time. Distance equal to speed multiplied by time. Now time equal to distance upon speed and speed equal to distance upon time. So this is the distance, speed, time triangle. If we remember this, then it will be easy for us to remember the formula. Distance equal to speed and time being on the same level, speed multiplied by time. Time equal to distance divided by speed, or time equal to distance upon speed. Similarly, speed equal to distance upon time. So if we remember this triangle, we'll be able to memorize we'll be able to remember the distance, speed, time formula. Now next is average speed. Average speed is total distance upon total time. And another formula for average speed is if x and y are two speeds for the same distance, then average speed equal to 2 into x into y upon x plus y. So this is our another average speed formula. We will learn it by few simple examples. So we go to the examples for understanding distance or time or speed questions. Very simple questions we will first take up, and we will try to understand the distance, time and speed formula. Let's solve one example for distance equal to speed into time formula. Here is the formula: distance equal to speed multiplied by time. So the question is, a car is traveling with speed 72 km per hour. How much distance would it cover in 2 hours 30 minutes? So our formula is distance equal to speed multiplied by time. Here speed is given 72 km per hour and time is 2 hours 30 minutes, which is 2.5 hours, which is equal to 5 upon 2 hours. So we cancel 2 of denominator and 72 of numerator for 36 times. So 36 multiplied by 5 equal to 180 kilometer. So distance traveled is 180 kilometer. We are solving few simple examples to understand the formula. So distance equal to speed multiplied by time. Speed is 72 and time is 2.5 hours. So we multiplied both and we got the answer 180 kilometer. We go to next example. Our second example is a car travels with speed of 60 km per hour for 2.5 hours and 70 km per hour for 2 hours. What is the distance traveled by the car? So total distance equal to speed into time, which is S1 T1 for the first part and S2 T2 for the second part. For the first part, speed is 60 km per hour and time is 2.5 hours, which is 5 upon 2 hours. Plus in second part, the speed is 70 km per hour and time is 2 hours. So we calculate like this. We cancel the denominator of 2 and numerator of 60, which 2 divides 60 for 30 times. So this is equal to 30 multiplied by 5 is 150 plus 70 multiplied by 2 is 140. This gives us 290 kilometer. So distance traveled is 290 kilometer. Here we have learnt the formula distance equal to speed multiplied by time. We go to the third example for solving the speed, and we have again made the distance, speed, time triangle here, and we read the questions like this. Sanjay travels with 5 upon 8 of his usual speed and covers 40 km in 80 minutes. Find his usual speed. Now we saw like this. So his current speed is, the distance traveled is 40 km and speed is distance upon time. So time is 80 minutes. So we convert it into hours. So 80 divided by 60. This is equal to 40 upon 80 multiplied by 60. 40 divides 80 for 2 times and 2 divides 60 for 30 times. So this is equal to 30 km per hour. Now this is not Sanjay's actual or usual speed. It is the 5/8 of his usual speed. So we have to find the usual speed. So if x is his usual speed, then 5x upon 8 equal to 30 km per hour. So x equal to 30 multiplied by 8 divided by 5. 5 divides 30 for 6 times. So 8 multiplied by 6 equal to 48 km per hour. So Sanjay's usual speed is 48 km per hour. This way we can find the speed, which is nothing else but distance divided by time, or distance upon time is speed. Now we go to the next question for finding time, and time is distance upon speed. Here distance upon speed equal to time. So our question is, Abdul runs for 6000 meters at a speed of 12 km per hour. How much time in minutes he takes to complete this distance? So we solve like this: time equal to distance upon speed. So this is equal to 6000 meter, and we have to convert it into kilometer because the speed given is in kilometer per hour. So we divide it by 1000 upon 12 km per hour. So we divide it by 12. So this is equal to 6 upon 12, which is equal to 1 upon 2 hours. So this is equal to 1 upon 2 multiplied by 60, as each hour has 60 minutes. So half multiplied by 60 equal to 30 minutes. So our answer is 30 minutes. And the formula we have used is time equal to distance upon speed. We are taking all simple questions to understand the formula. Now we are going to solve the question on average speed. And average speed is total distance upon total time, and we will understand it by this example. So our example is, A goes to market by taxi with speed of 40 km per hour and comes back halfway walking with speed 4 km per hour and balance halfway by auto rickshaw with speed 30 km per hour. Find his average speed. So our formula for average speed is average speed equal to total distance upon total time. In this question, A goes to market with speed 40 km per hour and comes back with halfway with speed 4 km per hour and halfway with speed 30 km per hour. So let the distance be d, then the distance for going is d and for coming also it is d. So time t1 for going equal to d upon 40, as the speed for going is 40. Time t2, which is halfway for coming, halfway is d by 2, and the speed is 4 km per hour. So d by 2 divided by 4, which is equal to d upon 8, and t3 is the another halfway or balance halfway which he travels by auto rickshaw with speed 30 km per hour. So time taken t3 equal to d by 2 upon 30, which is equal to d upon 60. Now average speed is total distance upon total time. So average speed, the total distance is twice of d, which is d for going and d for coming. So this is 2d upon total time, which is t1 plus t2 plus t3. So t1 is d upon 40 plus t2 equal to d upon 8 plus t3 equal to d upon 60. So this is equal to 2d upon the LCM of 48 and 60 is 120. 40 divides 120 for 3 times. So this is equal to 3d. 8 divides 120 for 15 times. So it is equal to 15d plus 60 divides 120 for 2 times. So it is equal to 2d. So the denominator of denominator is numerator, so we multiply like this, 2d multiplied by 120 upon 3 plus 15 plus 2 is 20d. So denominators, d cancels the numerator of d, and 20 cancels 120 for 6 times. So this is equal to 6 multiplied by 2 equal to 12 km per hour. So the average speed, which is equal to total distance upon total time, here this gives the answer 12 km per hour. We are going to use the another formula for average speed. In this formula, if the distance is same and the speeds are different for two equal distances, then the average speed is given by, we use the formula average speed equal to 2xy upon x plus y. So the question in the example is, a car goes half distance with speed 30 kilometers per hour and another half with 45 kilometers per hour. What is the average speed of the car? So here x is the distance for half distance, which is 30 km per hour, and another half is 45 km per hour, or we can say x equal to 30 km per hour and y equal to 45 km per hour. So here the average speed equal to 2 into 30 multiplied by 45 upon 30 plus 45, which is equal to 2 multiplied by 30 multiplied by 45 upon 75. So we cancel 15 times 75 equal to 5, and 15 divides 45 for 3 times, and 5 divides 30 for 6 times. So 6 multiplied by 2 multiplied by 3 is 36. So average speed is 36 km per hour. We go to extra formula for finding the ratio of the two speeds. If two persons A and B are moving in opposite direction, A from point X to Y with speed SA and B from Y to X with speed SB, and cross each other at point O. After crossing, their time for reaching to their destinations are TA and TB respectively, then ratio of their speed is given by speed of A upon speed of B equal to under root of time of B upon under root of time of A. Here we have to remember that they are reciprocals. When numerator is speed of A on left hand side, then the numerator of right hand side is under root of time of B, not time of A. Or we can, for memorizing, we can write like this: speed of A, SA, into time of A under root, or SA into under root TA equal to SB into under root TB. This way we can memorize it. So this is the shortcut formula for finding the ratio of their speeds, and if speed of one is given, we can find the speed of other. Once again, try to understand this formula. A is moving from X to Y and B is moving from Y to X, and they cross somewhere at point O, and after crossing, the time taken by A for reaching to OY is TA, and time taken by B for OX is TB. Then the speed of A upon speed of B equal to under root of time of B, which is TB, and upon under root of TA. This way we have to understand the formula, and we can write SA under root TA equal to SB into under root TB. And now we go to one example for this formula. and we solve it to understand this formula properly. We go to the example. Kishan goes from Kolkata to Mumbai and Ramesh from Mumbai to Kolkata at the same time. They cross each other and complete their travel in 64 hours and 49 hours respectively after meeting each other. Find ratio of speed of Kishan to the speed of Ramesh. If speed of Ramesh is 32 km per hour, find speed of Kishan. So we solve like this. Speed of Kishan upon speed of Ramesh, we write speed of Kishan as Sk and speed of Ramesh as Sr equal to under root of time of Ramesh upon under root of time of Kishan, which is under root of Tr, which is time of Ramesh, and under root of Tk, which is time of Kishan. So this is equal to, the time of Kishan is 64 and time of Ramesh is 49. So we write time of Ramesh first on numerator, which is 49, upon time of Kishan, which is 64. This is equal to 7 upon 8. So the ratio of speed of Kishan to speed of Ramesh equal to 7 upon 8 or 7 ratio 8. Now we have been given the speed of Ramesh. So we put the value of speed of Ramesh and find out the speed of Kishan. So speed of Kishan upon speed of Ramesh, which is equal to 32 km per hour, equal to 7 upon 8. This gives us speed of Kishan equal to 7 multiplied by 32 upon 8, and 8 cancel 32 for 4 times. This is equal to 28 km per hour. So this way we can solve the question and find out the ratio of the speeds of the two persons if they are traveling the same distance and moving in opposite direction, and after crossing each other, if the time of completion of their journey is given, we can find out the ratio of their speeds. Now we go to types of questions usually asked in the competitive exams or placement interviews, and we find out the shortcuts of solving it by actually solving few questions. But first we discuss the types of questions usually asked in the exams. So first type of the questions which are asked when the distance is constant. When the distance is constant, then d equal to s1 into t1 equal to s2 into t2. That is, when the distance is constant, then speed 1 into time 1 equal to speed 2 into time 2, or s1 t1 equal to s2 t2. In second type of questions, when speed is constant or speed is same, in that case speed equal to distance upon time. So d1 upon t1 equal to d2 upon t2. Third type of questions asked are when time is constant, when time is same. So time equal to distance upon speed. So d1 upon s1 equal to d2 upon s2. Fourth type of questions are asked on average speed. We have already solved the example of average speed, in which the formula is total distance upon total time. And fifth type of questions are miscellaneous questions involving all these things, and we will solve some miscellaneous questions as well. Usually the time given in the questions are very limited for solving the aptitude questions. So the questions are in general very easy questions, so that we can solve them within a minute or so and give the answers. So we have to solve these questions with utmost concentration and using all these formulas, so that we can save our time and reach to the answer fast. Now we go to the few questions based on these formulas and solve it. So we solve the first question. A car covers certain distance in 10 hours with a speed of 60 km per hour. What should be the speed of car to cover the same distance in 15 hours? Here the distance is same. So distance equal to speed into time. So what we write? S1 T1 equal to S2 T2. This is our formula. And now we solve like this. S1 is 60 km per hour and T1 is 10 hours. Now T2 is given to us as 15 hours and S2 has been asked to us. So S2 into 15. So this gives us S2 equal to 60 into 10 upon 15. 15 cancels 60 for 4 times and 10 multiplied by 4 equal to 40. So our answer is 40 km per hour. Just we have used the short trick of S1 T1 equal to S2 T2 and we have reached to the answers. We go to question second. A train has speed 50% more than a car. Both start from a point P at the same time and reach to the point Q 90 kilometers from P at the same time. Train, however, had stopped for 30 minutes in stations in between P and Q. Find the speed of the car. So we solve like this. Let the speed of the car be S, then speed of train, which is 50% more than that of car, equal to 3s upon 2 or 1.5 s. Now as the speed of train is more, so it will take less time to reach the destination, but it had stopped for 30 minutes, which is equal to half hour. So time difference between the car and train is half hour. We write time of car minus time of train equal to 30 minutes equal to half hour. As the speed has been given in kilometer per hour, so we have to take the time in the similar unit, which is hour. Now we solve like this. Time of car is distance upon speed. So distance given to us is 90 kilometer. 90 upon speed of car is s minus 90 upon speed of train is 3s upon 2, which is equal to half an hour. Now we solve this question. 90 upon s minus 90 into 2 upon 3s equal to 1 by 2. So we cancel 3 of denominator to 90 of numerator for 30 times. So this gives us 90 upon s minus 60 upon s equal to 1 by 2. LCM is s and 90 minus 60 equal to 1 upon 2. So 30 upon s equal to 1 upon 2. This gives s equal to 2 into 30, which is 60. So s equal to 60 km per hour. So speed of car is 60 km per hour. Though it is not asked the speed of train, but it is 50% more than that of car. So speed of train is 50% more than 60, which is equal to 90 km per hour. We go to the third question. A covers a distance of 60 km taking 2 hours more than B. If A doubles his speed, then he would take 1 hour less than B. What is speed of A? Again, here the distance is constant or distance is same and the speed is varying. So we solve like this. Let time of B be T and speed of A be S. Time taken by A in first case is let it be T1 equal to distance upon speed, which is 60 upon S, and this time is 2 hours more than that of B, so it is t plus 2. And in second case, when the speed is doubled by A, then let the time be t2, then it will be equal to 60 upon double the speed is, which is 2s, and the time taken is 1 hour less than that of B. So that is equal to t minus 1. Now if we subtract t1 minus t2, this is equal to 60 upon s minus 60 upon 2s, which is equal to t plus 2 minus within bracket t minus 1. We cancel 2 of denominator to 60 of numerator for 30 times, and this gives us, we take the LCM s, 60 minus 30 equal to t plus 2 minus t plus 1. We cancel this plus t and minus t, and this is equal to 3. Now 60 minus 30 is 30. So 30 upon s equal to 3. This gives s equal to 10 km per hour. So speed of A is 10 km per hour. Here the time was same, and we had taken the short trick of t equal to d upon s, and we reached to the answer fast. Question 4th. A man moves 3 km per hour faster than his usual speed. He takes 40 minutes less, and if he moves 2 km per hour slower, he takes 40 minutes more for the same distance. What is the distance and usual speed? So we solve like this. Let d be the distance. Let x km per hour be the usual speed. Now in first condition, when he is moving 3 km per hour faster than his usual speed, then speed will become x plus 3. And the time taken is 40 minutes less than the usual time. So we take the difference of the two speeds. So when he is moving with the speed x, which is his usual speed, then time taken is d upon x. And when he is moving with 3 km faster, then time taken will be d upon x plus 3. And this difference is 40 minutes, which is equal to 40 upon 60 hours. So this is 2 upon 3. So we give this equation as equation number 1. And now we go to the second condition. When the speed is lowered by 2 km per hour, then the time taken will be 40 minutes more. So we write like this. When the speed is made 2 km per hour less than usual speed, the time will be d upon x minus 2 minus usual time. If we take d upon x, then this is equal to again 40 minutes, which is 40 upon 60 or equal to 2 upon 3. Now we give the equation number 2 to this equation, and we find that the left hand side of both can be equated because right hand side is 2 upon 3. So we equate both sides. So we get d upon x minus d upon x plus 3 equal to d upon x minus 2 minus d upon x. We divide both sides by d. So we get 1 upon x minus 1 upon x plus 3 equal to 1 upon x minus 2 minus 1 upon x. This gives us x into x plus 3, LCM of left hand side, which gives x plus 3 minus x in numerator equal to the LCM of right hand side is x into x minus 2. This gives x minus x plus 2. So both sides x's are cancelled, and also x is cancelled in denominator. This gives us 3 upon x plus 3 equal to 2 upon x minus 2. On cross multiplication we get 3x minus 6 equal to 2x plus 6. On solving, we get 3x minus 2x, which is equal to x, equal to 6 plus 6 equal to 12. So speed is 12 kilometer per hour. Usual speed of the person is 12 kilometer per hour. Putting this value in equation number 1, we can get the distance. So we solve like this. Our equation number 1 is d upon x minus d upon x plus 3 equal to 2 upon 3. And we put the value of x, which is 12. Then we get d upon 12 minus d upon 12 plus 3 is 15 equal to 2 upon 3. Our LCM for 12 and 15 is 60. So this gives us 5d minus 4d equal to 2 upon 3. We cancel 60 by 3 for 20 times, and this gives us 5d minus 4d equal to d, which is equal to 20 times 2 is 40. So d is 40 kilometer. So our answer, usual speed equal to 12 kilometer per hour and distance equal to 40 kilometer. So this was very easy question. We have taken the d constant and subtracted the speeds and reached to the answer fast. We solve question number 5. A person walks at 10 km per hour and covers certain distance d. If he increases his speed by 50%, he covers 20 km more. What is the distance d? Here time is constant or time is same. So we solve like this. Time equal to distance upon speed. So d1 upon s1 equal to d2 upon s2. Now we have been given, in first case the distance is d and second case distance is 20 km more than d. So it is d plus 2. And in first case speed is 10 km and in second case the speed is 50% more. So 50% of 10 is 5. So 50% more is 15 km per hour. So we solve like this. d1 is d upon 10 equal to d plus 20 upon 15. So we cancel 10 by 5 for 2 times and 15 for 3 times and cross multiply it. So we get 3d equal to 2d plus 40. This gives us 3d minus 2d equal to d, which is equal to 40. So distance is 40 km. Very easy question. Just we have to take the time constant and we have done it in a very fast way. We solve question number 6. Amit and Abdul are at P and Q 120 km apart. Move towards each other and reach to their destinations and return immediately and meet at point R. The speed of Amit is 20 km per hour and speed of Abdul is 30 km per hour. What is the distance between Q and R? So we saw like this. This is point P and this is point Q. And Amit is starting from point P and Abdul is starting from point Q. Amit reaches to point Q and returns back. And Abdul starts from point Q, reaches to point P and returns back, and they meet at point R. And we have been asked the distance between R and Q. So let the distance between R and Q be x. Then distance between P and R will be 120 minus x. As the distance between P and Q is 120, so P and R will be 120 minus x. Now it has become very easy to solve it. So we solve like this. So distance traveled by Amit is 120 plus x. Abdul has traveled 120 plus 120 minus x. As distance between P and R is 120 minus X. So Abdul has traveled 120 from Q to P plus P to R is 120 minus X. So now we have the distance traveled by Amit and Abdul, and both have taken the same time. Here time is same. So we can equate the time and we can reach to our answer. So time taken by Amit is 120 plus X, which is distance upon speed. The speed of Amit is 20 km per hour. So 120 plus X upon 20 equal to 120 plus 120 minus X upon 30. Now we have the equation and we can solve it very fast. So we cancel zeros on both sides of denominator and cross multiply it by 120 by 3, which gives us 360 plus 3x equal to 120 plus 120, which is equal to 240 minus x. So 240 multiplied by 2, which is 480 minus 2x. On transferring we get 5x equal to 480 minus 360 is 120. 120, 5x equal to 120. Therefore, x equal to 120 divided by 5, which is equal to 24 km. So distance between R and Q is 24 km. Question number 7. A car goes from city A to B with speed 40 km per hour and returns back with speed 60 km per hour. What is the average speed of the car? Usually the mistake we do in solving this question is we add 60 plus 40, which is 100, and divide it by 2 for making the average, which comes out to be 50. But this is the wrong method and we should solve it properly. So we solve it with the first method. Here the average speed has been asked. So average speed is total distance upon total time. Let the distance be d in between A and B. Then total distance for going and coming will be 2d. And time for going equal to d upon 40. And time for coming equal to d upon 60. Now we have got the total time, which is time for going plus time for coming, and we have got the total distance, which is d for going and d for coming. So that comes out to be average speed equal to total distance traveled is 2d upon total time, which is t1 plus t2, or time for going and time for coming, which is equal to d upon 40 plus d upon 60. So this is equal to 2d upon the LCM of 40 and 60 is 120. This is 120. So this will be 3d plus 2d. This is equal to 2d multiplied by 120 upon 3 plus 2, which is 5d. We cancel d and cancel 120 by 5 for 24 times. So this gives us average speed equal to 24 multiplied by 2, which is 48 km per hour. Now we can do it by shortcut method. If the distance is same, then the average speed can be calculated by a shortcut formula. So we solve like this with alternate method. If the distance is same and speeds are different, then if the speed for one way is say x and for coming it is y, then average speed equal to 2 into x into y upon x plus y. So this gives us 2 multiplied by 40 multiplied by 60 upon 40 plus 60, which is 100. 2 multiplied by 40 multiplied by 60 upon 40 plus 60, which is equal to 100. So this gives us 2 multiplied by 40 multiplied by 60 upon 100, and we cancel zeros of denominator by zeros of numerator, and we get 2 multiplied by 4 multiplied by 6, which is 6 times 4 is 24 times 2 is 48 kilometer per hour. So this way we can solve it by shortcut method by using the formula for same distance. If the two different speeds are there, then the average speed is 2 into x into y upon x plus y. We solve the question 8. A man covers first half of the distance at a speed of 21 km per hour and second half of the distance at speed of 24 km per hour. If time taken by him is 10 hours, find the distance covered by him. Here the distance for both the speed is same. So we will first find out the average speed and then we will multiply it by time and we will get the distance covered by him. So as the distance for both the speed is same, we use the formula of average speed like this. Average speed equal to 2x into y upon x plus y. Here x is the speed for first half and y is the speed for the second half. So the speeds given to us are 21 and 24. So 2 multiplied by 21 multiplied by 24 upon 21 plus 24. So this is equal to 2 multiplied by 21 into 24 upon 45. So we cancel 45 by 3 for 15 times and 24 by 3 for 8 times and 15 again by 3 for 5 times and 21 for 7 times. So this gives us 112 upon 5 kilometer per hour. 8 multiplied by 7 is 56 multiplied by 2 is 112 and 112 upon 5 kilometer per hour. Now distance equal to average speed multiplied by time. This gives us 112 upon 5 multiplied by 10. We cancel 10 by 5 for 2 times. So the distance is 112 multiplied by 2. It is equal to 224 kilometer. This way we can solve this question. Question number 9. A man when travels at a speed of 10 km per hour, he reaches his destination at 2 p.m. If he travels at a speed of 15 km per hour, he reaches at 12 noon. What should be his speed so that he reaches the destination at 1 p.m.? Here we solve like this. Time for 2 p.m. equal to t. When he starts at some time and reaches to 2 p.m., then the time is t. Then time for 1 p.m. equal to t minus 1 and time for 12 noon equal to t minus 2. Now here the distance is same. So what we write? D equal to speed 1 s1 into t1 equal to s2 into t2. Also s1 into t1 equal to s3 into t3. Here s1 is the speed which is 10 km per hour. S2 is the speed which is 15 km per hour where the person is reaching at 2 p.m. and then at 12 noon. And S3 is the speed asked to us for reaching at 1 p.m. So now we solve like this. S1 is 10 km multiplied by T1 is T equal to 15 into T minus 2, which is reaching at 12 noon. This is our equation number 1. And in second case, 10T equal to S3, which is asked to us, into T minus 1, which is 1 p.m. This is equation number 2. Now, on solving the first equation, we get 10T equal to 15 T minus 2. We cancel 10 for 2 times by 5 and 15 for 3 times by 5. 2T equal to 3T minus 6. This gives T equal to 6 hours. If we put the value of T in equation number 2, then we get 10 into 6 equal to S3 into 6 minus 1, which is equal to 5. So 10 multiplied by 6 upon 5 equal to S3. We cancel 10 by 5 for 2 times. Therefore, S3 equal to 6 multiplied by 2, which is 12 km per hour. So if the person moves with 12 km per hour, he will reach at 1 p.m. Now this question can easily be solved by alternative method of average speed, as the time between 12 noon and 2 p.m. is 1 p.m., which is the mean of these two times. So if he moves with the average speed of 10 and 15, he will reach at 1 p.m. So we solve like this. Average speed equal to 2 into x into y upon x plus y, which is equal to 2 into 10 multiplied by 15 upon 10 plus 15. This is equal to 2 multiplied by 10 multiplied by 15 upon 25. This cancels. 25 is cancelled by 5 for 5 times and 15 for 3 times, and 5 again is cancelled for 1 time by 5, which cancels 10 for 2 times. So this is equal to 2 multiplied by 2 multiplied by 3, which is equal to 12 km per hour. So this way we could have solved it in a shortcut method. Question 10. At an airport, conveyor is moving with speed of 3 meter per second between 2 points 120 meter apart. If a person walks on moving conveyor belt with speed 1 meter per second in the direction of moving belt, how much time will he take to cover the distance? Here the conveyor belt is in between 2 points, which is 120 meters apart, and a man is moving on it with the speed of 1 meter per second, and the speed of conveyor is 3 meter per second. So the relative speed as the belt is moving and on which the man is also moving in the same direction, so both the speeds are added as both are moving in the same direction, and one is helping, or belt is helping the man to move forward and adding his speed. So we get the relative speed equal to 3 meter plus 1 meter, which is equal to 4 meter per second. Now we have been asked the time. So time is distance upon speed. So time equal to, distance is 120 meters and speed is 4 meter per second. So 120 divided by 4, which is equal to 30, that is 30 seconds. So man will be reaching to point where the conveyor ends is 30 seconds. So he will be reaching in 30 seconds. This is the question of relative speed, and we have to add the speed in this case. Two persons start running in a circular track of length 800 meters in opposite direction with speed 16 km per hour and 20 km per hour respectively. After what time they will cross each other for the first time? This question is of relative speed. Here the persons are running in opposite direction in a circular track. So the relative speed equal to 16 km plus 20 km. So 16 plus 20 equal to 36 km per hour. As the distance is in meters, so we should convert the speed kilometer per hour into meter per second. So 36 km per hour equal to 36 multiplied by 5 upon 18. For converting kilometer per hour to meter per second, we should multiply it by 5 upon 18. So 18 cancels 36 for 2 times. So this is equal to 10 meter per second. The distance is 800 meters. So time equal to distance upon speed. This is equal to 800 divided by 10. This is 80 seconds. So they will be meeting for the first time after 80 seconds, which is equal to 1 minute 20 seconds. We go to question number 12. Two planes are 2940 km apart. moving towards each other and crosses after 6 hours. If their speeds differ by 90 km per hour, find their speeds. These are our two planes and the distance between them is 2940 km from each other. One is moving with speed, let the speed of one plane be x km per hour. Then the speed of the another plane will be x plus 90 km per hour, as it is given that the speed differ by 90 km. So now relative speed between them equal to x plus 90. So this is equal to 2x plus 90. Now it is given that time when they cross each other is 6 hours. So this is equal to distance upon speed. This is equal to 2940 upon the relative speed is 2x plus 90. And this is given that the time is equal to 6 hours when they cross each other. So this is equal to 12x plus 540 equal to 2940. This gives 12x equal to 2940 minus 540, which is equal to 2400. This gives x equal to 200 km per hour. So speed of first plane is 200 km per hour. Speed of first plane or one plane is 200 km per hour and speed of other plane is x plus 90. So it is 290 km per hour. Question 13. Excluding stoppages, speed of train 75 km per hour and including stoppages, its speed is 60 km per hour. For how many minutes train stop per hour? Difference of speed equal to 75 minus 60 equal to 15 km per hour. If there had no stoppages, then train would have traveled 15 km more per hour than the present situation. So this is the time of stoppages where the train stops in stations. Therefore, time of stoppages per hour equal to distance is 15 km and speed is 75 km. So this is the time which the train uses for stoppages. We cancel 15 times 1 and 75 by 15 is 5 times 15 is 75. So this is equal to 1 upon 5 hours, which is equal to 12 minutes. So train stops for 12 minutes per hour on the stations. Question 14. Two buses A and B start from the same point. A moves towards north and B towards east. Speed of A is 2 km more than the speed of B. If after 5 hours they are 290 km away from each other, find their speeds. So we solve like this. Let speed of bus B is x km per hour and of A is x plus 2 km per hour. As they differ by 2 km, so the speed of B is x km per hour and that of A is x plus 2 km per hour. After 5 hours, distance traveled by A is 5 into x plus 2 km and by B is 5x km. Now they had started from O and B has reached to Q, which is 5x km, moving towards east, and A has moved towards north and has reached to point P, and the distance OP is 5 into x plus 2 km and distance OQ is 5x km. We join PQ and it is given that the distance between P and Q is 290 km. So we solve like this. We apply the Pythagorean theorem and according to that 5x square plus 5x plus 2 square equal to 290 square. 25x square plus 25 into x square plus 4x plus 4 equal to 290 square. Dividing both sides by 25, we get x square plus x square plus 4x plus 4 equal to 290 multiplied by 290 upon 25, and we cancel 25 by 5 and 290 and 290 by 5. So on cancelling 25 we get numerator as 58 multiplied by 58. So this is equal to 2x square plus 4x plus 4 equal to 58 multiplied by 58. Dividing both sides by 2, we get x square plus 2x plus 2 equal to 29 multiplied by 58. This is equal to 1682. This is equal to x square plus 2x minus 1680 equal to 0. This is equal to, we split 1680 into two parts such that their addition is 2. So we do like this: x square plus 42x minus 40x minus 1680 equal to 0. This gives us, we take common x, this gives us x plus 42 minus 40 into x plus 42 equal to 0. So this is equal to x minus 40 into x plus 42 equal to 0. Therefore x equal to 40 or x equal to minus 42. Minus 42 is not acceptable as the speed cannot be negative. Hence the speed of B equal to 40 km per hour and speed of A equal to 42 km per hour, as the speed of A is 2 km more than that of B. This way we find the speed of bus A and B. Question number 15. A man travels a distance of 60 km in 9 hours, partly walking with speed 5 km per hour and partly by cycle with speed 8 km per hour. Find distance traveled by walking. So we saw like this: let distance traveled by walking be x kilometer. Therefore distance traveled by cycle equal to 60 minus x kilometer, as the total distance traveled is 60 km. Now we take the time which is given to us is 9 hours. So we calculate the time of walking as well as the time of cycling. So time for walking is, distance is x kilometer and the speed of walking is 5 km per hour. So it is x upon 5 plus 60 minus x, which is distance of cycling, upon 8 km per hour is the speed of cycling. So 60 minus x upon 8 is the total time, equal to 9. This is 9 hours. So we multiply both sides by LCM of 5 and 8, which is 40. On multiplying both sides by 40, we get 8x plus 60 into 5 is 300 minus 5x equal to 9 into 40 is 360. This gives us 8x minus 5x equal to 3x. This is equal to 360 minus 300 is 60. Therefore x equal to 20 km. So distance traveled by walking is 20 km. In this aptitude video of speed, distance and time, we have covered almost all type of questions in which when the distance was fixed or distance was constant, when the time was constant, when the speed was constant, and we have also covered the questions of average speed, relative speeds and other miscellaneous questions. These questions will help you to cover this topic. Here complete this video. Please like, share and subscribe to this channel. Also press bell icon to get the latest notifications.